In this final task of Lab 3, we'll explore the UTM Coordinate System. I have right now QGIS Desktop open with the WorldView UTM map document open, and you can see the same land, cities, and circles theme that we've been working with in this lab. There's a new layer now. It's the UTM zones. We've just covered the state plane coordinate system, and UTM is similar to state plane in some respects. It is comprised of zones. However, Universal Transverse Mercator, known as UTM, is a Cartesian or plane coordinate system that spans the entire globe. It's probably the best known Cartesian coordinate system of international scope. In the UTM system, the globe is divided into 60 zones, each comprised of 6 degrees of longitude. Each zone has its own central meridian, and the limits of each zone run from 84 degrees north down to 80 degrees south, so it covers the bulk of the populated lands in the world. Each UTM zone uses a custom transverse Mercator projection, and the zones are numbered from 1 to 60. So starting here at the international date line, we start with zone 1, and they run up consecutively to zone 60. So let's start, as we've been doing, by checking the coordinate reference system of our map. Go to Project Properties and open up the CRS tab. And I can see the map is in WGS84 as we've become familiar. What I'm going to do is enable on-the-fly CRS transformation, and I'm going to change the coordinate system of this map into a particular UTM zone. I'm going to change this into UTM zone 32. This happens to be the zone that the majority of Denmark falls into, and this is where the next QGIS user and developer meeting is going to be held. So I'm going to type zone 32 into the filter to narrow my choices down, and you can see there are different zone 32 definitions with different datums. I'm going to choose the one with WGS84 as the datum and click OK. And this will take a little bit to render. It's having to force the rest of the world into this narrow cylindrical projection that it's not really designed for. So typically we would not be using UTM unless your study area fits neatly into the UTM zone. So here you can see the result, and the map is very distorted. Again, this is just intended for study areas that fit within the zone. If I zoom into Denmark, you'll see how Denmark, for the most part, fits within this one zone. So this would be suitable for a piece of geography such as that. Now I'm going to bring up the country view, and we can look at UTM zones related to the United States. So here in the continental lower 48, we have 10 zones. Many U.S. federal agencies use the UTM system. For example, the Forest Service and the BLM will use UTM for mapping regional data sets. So this time I'm going to go to Project Properties, and I'm going to change the map to be in UTM Zone 13. This happens to be the zone that I'm recording this video in. I'm going to choose the NAT83 datum and click OK. And you can see now that we are centered on UTM Zone 13. In this Task 5, you'll do something similar and explore putting these QGIS map documents into a zone that you're situated in to see how the map changes. In Lab 3, you've learned how to work with coordinate reference systems within a QGIS map document. You've also learned how to create a custom CRS definition and how to reproject a shapefile to a new CRS. Along the way, you've explored world, national, and state projections and coordinate systems.